Okay, AP Physics, let's make sure we've got these things down. This is going to be one of several to make sure that you're up to speed on where you need to be for this unit acceleration. So the first thing we need to look at is position versus time graphs, and that's going to be the subject of this video. On a position versus time graph, you need to make sure that you know that the slope of this line here is the speed. And the reason that's the speed is because this right here indicates constant motion. If the line is linear, it is a constant motion graph, constant velocity. So the slope of this line, if you'll notice, would be the change in position over the change in time, which hopefully you know by now is the same as the average velocity. And so since this is a constant velocity graph, the average velocity and the constant velocity would be the same. So on a straight line, position versus time graph, change in velocity, or sorry, change in position over change in time equals change in velocity. That is otherwise known as the slope. Alright, let's move on to a slightly more complicated one. So on this one, what I want to make sure that you understand is that if the graph is curved, it doesn't matter which way it's curved, but this way it's curved, right? It is accelerating. If it is curved upwards, it's a positive acceleration. And if it's curved downwards, it's a negative acceleration. So if the curve is up, it's a positive acceleration. If it's down, it's a negative acceleration. These curves can be less steep. So for instance, here's one that's going from a constant velocity and slowing down, right? The curve here indicates that it's slowing down because it's a negative curve. It's not up, it's down. So these curves can be slight. They don't have to be super steep. But a curve up is positive, a curve down is negative. All right. In addition to that, we also have the formula that goes with this. So you might want to remember that the formula associated with this graph is the formula x equals 1/2 at squared plus v naught t plus x naught, where x naught is this position here, v naught is the initial velocity, 1/2 a is the 1/2 of the acceleration. But this formula that you have for position will get you the graph for acceleration, or sorry, will get you the graph of an accelerating object. All right, and just in case this comes up, you can still find the average velocity for this one by doing the same thing you've always done: change in position over change in time. So if you need to find the average velocity for this graph, you can still do it. Note that the average velocity for this graph would be along that line, right? So it would not necessarily be the speed up here. It might be the speed somewhere in here, but it's going to be going faster up here because the speed's constantly changing. But you can still find the average velocity by doing the change in position over change in time. All right? Let's look at one last thing. Let's try to identify what all these things are doing. So we've got 4 sections here. So let's try to identify what's happening in each section. So in the first section, what we want to do is we want to notice that it's curving upwards, so that means the object is speeding up. It has a positive acceleration. In the second section, you should notice that it's a straight line, or relatively straight, okay? And so that means that it is moving at a constant rate of speed, a constant velocity. And then in that third section, it comes to a complete stop. How do I know it's come to a complete stop? Well, notice that the time is moving along, but the position isn't changing. So that indicates that it's come to a halt. And in this fourth section, it begins accelerating in the negative direction. So what that means is that it is speeding up, but back toward the starting position. Okay? So that is possible. All right? So this is just a brief overview. It's not comprehensive, but it's a brief overview of position and time graphs. If you have any questions over this, please feel free to email me. You will need to make sure that you understand this stuff for the upcoming exam. All right?